Good morning, all of you. This is Vishnu. Welcome to Vishnu's lectures. So today we are going to discuss about compilation stages and types of errors at compile time. Okay. First, before discussing about compilation stages, let me know what is compiler first. This already we covered. What is a compiler? This already covered in our first lectures. Okay. So what is a compiler? It is a software which converts high level language into low level language or machine level language. But before that, let's observe this program. What is this? This is a program. Consider this is a high level language. So this is a high level language. How many statements this program contains? This program contains 3 statements, 1, 2, 3. What it contains? A equal to 10, B equal to 20, int prod equal to A into B, right? And printing prod. So what is the answer for A into B? Means 10 into 20, 200. So I'm asking a question, who is executing all these 3 statements? Who is going to be execute all these 3 statements? Who is going to be execute? CPU will execute. What is the meaning of execution? I already told this. Whenever you are writing A equal to 10 means somebody has to assign this 10 value into A. Somebody has to assign this 20 value into B. Somebody has to add this A into B. Somebody has to print this. Who is doing all these things? Who is doing means CPU. Machine is doing. But the problem is, if I submit this code directly to the machine, this machine will not understand, because this machine will understand only zeros and ones. Means it will understand only binary language. So the CPU understands only binary language. Then what to do? That's why we need to use compiler here. So we need to use compiler. So give this program to the compiler first. What compiler will do? Compiler will convert this C program into executable file, means application, which is in binary format. Getting my point? So this executable file is in zeros and ones. Now this executable file is understandable by the CPU. What this executable file contains? This executable file contains same information. This information only, but in binary format. Who converted this? Compiler converted this from high level to binary. So this much clear. So what is the conclusion from this? After writing the program, first you have to compile the program, then only you have to execute. Who will execute? CPU will execute. So this much clear. Here we are going to discuss about mainly compiler, means compilation stages. So here some stages are there. Actually compiler means we have so many compilers like GCC, Turbo C, like Visual Studio. Some compilers will be there. So we'll discuss mainly GCC compiler. Okay, we are discussing GCC compiler. So compiler is divided into actually 4 parts. There are 4 stages in compiler that we are going to discuss. What are the 4 stages? 4 stages are preprocessor, translator, assembler, linker. All these 4 stages combinedly known as compiler. Means whenever you are compiling the program, by default all these 4 stages will be running internally. Getting my point? So today we are going to discuss about step by step preprocessor, translator, assembler and linker. Practically we will discuss by writing program. But before that we'll discuss step by step theoretically what preprocessor will do, what translator will do, what assembler will do and what linker will do. We'll discuss step by step. Okay. These four stages are part of compiler. Inside the compiler, there are four sub-programs are running: preprocessor code, translator code, assembler code, and linker code. Then only it's completely called as a GCC software. We'll discuss step by step. First, we'll discuss preprocessor. See here. Okay. See here. What is preprocessor? What it will do? It is the first stage in the compilation stage. It is the first stage. What it will do? Tell me. First step includes header file content. I already told in last class what is header file and all. What header file contains? Header file contains declarations of functions, variables and macros. It may be predefined or maybe user defined. That I told already in last class. So what preprocessor will do? It includes header file content. What is the header file here? See this program. This hash include stdio.h is a header file. What this hash include stdio.h contains? See here. See, this is header file. What this stdio.h contains? This header file contains predefined function declarations, macros declarations, and variable declarations. Getting my point? So, whenever you write hash include stdio.h, this content, this complete content should be included our program. Who will load this? Who will include this content means preprocessor. So preprocessor will include this printf declaration, scanf declaration, getchar declaration, putchar and so many declarations. Who will include? Preprocessor. From where? It will fetch from stdio.h. This is the stdio.h file. From this stdio.h file, preprocessor will fetch these declarations and include in our program. Getting my point? So preprocessor includes header file content, this stdio.h content. So this hash include, hash define, whatever the things you are going to start with hash, all these are treated as preprocessor directives. Hash if, hash else, hash end if, whatever start with hash, that technically treated as preprocessor directives. We'll discuss clearly in upcoming classes. So whatever starts with the hash, that is treated as preprocessor directives. So what preprocessor will do? It includes header file content. Step 1. So what header file contains? Declarations. So that declarations will be loaded into our program. Who will include? Preprocessor. Next, it removes comments. See here in the program, this is main // So whenever you use // this is treated as comments. This is treated as comment. This is main is a comment. So comments are not required in our program. That is just for readable purpose you are writing. That is not at all useful to your program. So it has to be removed. Yes or no? This is main is it's a comment, right? It's a comment. So comments are not useful to your code. It has to be deleted. Who will delete? Preprocessor will delete. So it removes comments. Getting my point? Simply it removes comments. Next, third point, replace macros. I already told in last class what is macro. Like hash define age 25. This is a macro. So wherever you use age in your program, that age will be replaced with 25. Again, hash define age 25 is a macro. And one more example, hash define marks 100. So this is a macro. So wherever you use marks in your program, this marks will be replaced with 100 simply. Who will replace this? Who will replace 100 in place of marks? Who is going to be do this task? Means preprocessor. Preprocessor replaces macros. And third point, conditional compilation. This as of now, we should not discuss this, because even though if I discuss, you should not understand. You may not understand, because conditional compilation is a different topic. We'll discuss based on condition. The code will be compiled. Some code will be not compiled to reduce the size of executable file. That is different concept. We'll discuss that later. As of now, just remember what preprocessor will do means it also perform conditional compilation. This much clear? And what is the fifth point? What is the fifth point? It converts high level language into pure C code. It converts, see, high level language is also C code, but it converts into pure C code. Sir, what is pure C code? See, here, what preprocessor did here? Preprocessor removes these comments and includes header file content, replace macros. Whenever this comments, means comment is unwanted thing, right? This comment, that header file also unwanted thing, because we required declarations. In place of declarations, that header file will be included. So whenever these unwanted things are removed at preprocessor stage only, we will get pure C code. That's why we are telling it converts high level language into pure C code. High level language may contains comments, header files, macros, all these done by preprocessor, and preprocessor will generate pure C code. In pure C code, there is no comments, no header files, no need to replace macros. All this done in preprocessor stage itself, right? Okay. I hope clear. Fifth point also. And one more important point, whenever you use GCC, by default, all these 4 stages are compiled at a time. Again, whenever you compile like GCC space prog.c, GCC means all 4 stages are included in GCC. But if you want to compile stage by stage, sir, I want to compile only preprocessor stage, then you can use this command. You can use this command. What is this command? GCC space -e prog.c -o prog.i. This is command used to compile only preprocessor stage. This is command only used in preprocessor stage. Okay. Next, in preprocessor stage, will you get errors? Yes. When you will get errors, if you are not writing the header file properly, consider hash include stdio.h. In a hash include stdio.h, I'm doing some spelling mistake. Hash include std.h, like that. Then error will come. This error will treated as preprocessor error, technically fatal error. Technically fatal error. So fatal error comes at preprocessor stage if you are doing something wrong in header file and all. Getting my point? If you want to compile only preprocessor stage, then use this command. Okay, now after preprocessor stage, the code will be submitted to translator stage. After preprocessor stage, the code will be submitted to translator stage. So here what translator stage will do? First step, translator checks for syntax errors. Translator checks for syntax, means if any syntax errors is there in your code, Consider comma is missing, semicolon is missing, variables are not declared. If any syntactical mistake in your program, then syntax error will be generated by the translator. Getting my point? Okay. And what translator will do? What translator will do? Translator converts pure C code into assembly code. What is assembly code information ka extension? .s extension. And again in preprocessor, what is preprocessor ka extension? Preprocessor information ka extension is .i extension. Getting my point? What translator will do? Translator converts pure C code into assembly code. Next, if you want to compile only translator stage, then you can use this command gcc space -s proc.i space proc.s. Means what is the meaning of this command? .i means preprocessor, .s means assembly. You are telling convert .i to .s. Next, assembler. What assembler will do? Assembler converts assembly language into object code. Assembler converts assembly language into object code. Getting my point? And very important, in assembler, there are no errors. Assembler converts assembly language into object code, which is .y extension. And in assembler, there is no errors in this stage. 99%, there is no errors from assembly stage. And this assembler converts assembly into object code. This object code is in binary format. Getting my point? Third stage of compilation stage is assembler, and this assembler converts from which language to which language? From assembly to object code, and this object code is in binary format. And if you want to compile only particularly this assembler stage, then you can use this command gcc space -c proc.s -o proc.o. This is the third stage. And at second stage, any errors? Yes, what are the errors? Syntax errors. At first stage, fatal errors. Who will throw fatal error? Preprocessor. Who will throw syntax errors? Translator. When any some programmatically any mistakes like syntax mistakes like semicolon you are missing, comma missing, or something like variable not declared. So that leads to syntax errors. In assembler, there is no errors. Okay. Next we'll discuss what is linker. So here, just a minute. So what linker will do? Linker links calling function to called function. Linker links calling function to called function. Linker adds library functions and generate executable file. I will tell what is calling function and called function. Linker links calling function to called function. Programmatically, I will discuss what is calling function and called function. Next, second step is linker adds library functions. What library contains? Library contains predefined function definitions, not declarations. Library contains predefined function definitions. So who will add that library function definitions? Linker. But what preprocessor is doing actually? Preprocessor is adding header file, means declarations from header file. Header file contains declarations, but library contains definitions. Who will add declarations? Preprocessor will add. Who will add definitions? Linker will add. See here. See here, second program, second diagram. This is library file like libc.so, libm.so. So these are some libraries. What it contains? Printf definition, scanf definition. This is the logic of printf. Without executing this logic, you cannot execute printf. Even if you are printing printf hello, you are thinking simply printf hello is printed. For printing hello, there is some logic to run. After running this logic only, you will get hello. Scanf is used to store data. You are thinking simply you are storing data. No, some logic has to run. Some logic has to executed by the CPU. When CPU executes this logic, then only you can able to store data by using scanf function. So all these are logics, some program, very important. This is very important. But here only declaration, just one word statements these are. But this is a lengthy program. Without this, your printf will not work. Of course, this is not required, but this is required. These are definitions. These are logics. Who are going to be include? Who are going to add all these definitions? Linker. Who is going to be add all these declarations? Preprocessor. So this is header file. Header file contains predefined function declarations, and this is library file. Library file contains predefined function definitions. Linker is going to add all these definitions, and preprocessor is going to include all these header file content, means declarations. I hope clear this much. Next, see here one more point what linker will do. Linker add library functions and generate executable file. Means at assembler stage you are getting binary, but binary is not having library files. Printf definition, scanf definition, it is not having library files. After linker stage only you are getting library file, because linker only including that libraries and it combines with object file. When linker combine libraries with object file, then you are getting executable file. Now executable file is also in binary format. Now we can execute this executable file now, because it is having library also. So interviewer may ask like, what is the difference between object file and executable file? What he will tell, object file is also binary file, but object file not contains any libraries. What is executable file? Executable file is also binary file, but in executable file libraries are included by the linker, because executable file is generated at the linker stage. And very important point, linker creates startup. Linker creates one function, one file, that is startup file, very important. So what linker creates? See here, linker creates startup. What startup contains? Startup contains main call. Who calls mains? Means startup. So startup contains main call and it contains proper exit procedure. Main call and it contains proper exit procedure. Getting my point? Who creates the startup? Linker will create. What startup contains? Main call and it contains exit call. Once if you start your program, you have to exit. Who will call the exit function? Means startup. Who creates startup? Means linker creates startup function. I hope you are clear. Now we'll discuss practically. See this program once. See here, this is main function, and in main what you are doing, execution always starts from main, because first who will activate? Startup will activate while your program in execution, and startup calls main function and it is having proper exit procedure. Whenever you execute your whenever you load your .exe file, first startup will activate. and startup will call the main function and control jumps to main function definition. Now this main function definition is executed, this statement executed, and printing in main executed. And in place of age, what will be replaced? It is a macro. So age, in place of age 23 will be replaced. Who will replace this 23? Whose responsibility? Whose responsibility is to replace the macros? Preprocessor. So preprocessor will replace this age with 23. And fun1 function call happen. When fun1 function call happen, control jumps to fun1 function definition. Who is calling this fun1 function? Main is calling. That's why main is technically treated as calling function. Fun1 is treated as called function. Main is treated as here calling function. Very important terminologies. And this fun1 function is treated as called function. Who is calling this fun1 function? This fun1 function call happen in main definition, right? So that's why fun1 function is treated as called function. Main function is treated as calling function. Next, when fun1 function call happen, control jumps to fun1 function definition. Now executes this statement, printing in fun1, and here you are simply writing age marks. Age and marks will be replaced already at preprocessor stage. This will be replaced with 23. Sorry, 20. I wrote 25, right? So age will be replaced with 25 and marks will be replaced with 100. Who replaced these macros? Preprocessor. And next, fun2 call will happen and control jumps to fun2 definition and execute all the statements in fun2 definition. So here, who calls fun2? Who calls fun2? Who calls fun2 means fun1. So fun1 is treated as calling function. Fun1 is treated as calling function. Fun2 is treated as called function because fun1 is calling fun2 function. Similarly here, who calls main function? Startup calls main function. So in with respect to main and startup is treated as calling function. Startup is treated as calling function. Main is treated as called function with respect to main and startup. With respect to main and fun1 function. With respect to main and fun1 function, main is calling function, fun1 is called function. With respect to fun1 and fun2 function, fun1 is calling function and fun2 is called function. I hope this much clear. Okay, we'll do this programmatically now. See here. So this is header file and these are macros. And this is fun1 declaration, fun2 declaration, and main function definition. This is main function definition, and this is fun1 function definition and fun2 function definition, right? Observe in main function what I wrote: int x equal to 10, y equal to 20, age semicolon, marks semicolon. So this age will be replaced with 25 by the preprocessor. This marks will be replaced with 100 by the preprocessor. And who will? So what is this meaning? This is a fun function call. So here fun1 is treated as called function. Main is treated as calling function. Who will link from calling function to called function? I already told linker will link calling function to called function. And if you observe in fun2 or in fun1 also, in fun1 I'm printing age and I'm printing marks, but I'm not declared any age and marks in fun1. It is a macro. And here in fun2, simply what I'm doing, age semicolon, age semicolon, age semicolon, marks semicolon, marks semicolon, like this. Who will replace this age? So preprocessor will replace this age with 25 and marks with 100. Observe this code, take a screenshot. Take a screenshot of this because later it is useful to you. While I'm explaining, you have to refer every time this program. That's why take a screenshot. Okay. Now I'm going to compile GCC space. Actually, we are going to compile like this every time. GCC space prog1.c. So whenever you are writing GCC, in GCC inside 4 stages are available. So by default, preprocessor, translator, assembler and linker. 4 stages are going to be compiled at a time by writing the command GCC. So all the stages are compiled. By writing GCC, you are compiling preprocessor also, translator also, assembler also and linker also. Sir, I want to compile step by step, stage by stage. Sir, I want to compile only preprocessor. Then you can compile. You know already, I already told the preprocessor command gcc space -e, gcc space -e, program name. What is the program name? prog1.c -o. What is the extension for preprocessor? prog1.i. Getting my point? This is the command to compile particularly preprocessor stage. gcc-v prog1.c-o prog1.i. Enter. In first stage, sir, what you are supposed to say here means in first stage, what is the first stage? Preprocessor. So in this stage, what happened? Macros will be replaced. Comments will be removed. Getting my point? So if you observe, comments are there or not? See, here in main function, observe, I am in main function, which is in blue color. That is comment or not? That is not necessary to your code. So that should be removed. Who will remove? Preprocessor will remove. Similarly, in fun1 function also, I am in fun1 function. That is a comment that has to be removed. Who will remove? Preprocessor will remove. We'll check this practically. See, just I'm compile preprocessor program. Preprocessor program extension is .i extension. C program is .c extension. Assembler is .s extension. Object is .o. Executable file .exe. So for every information having some extension. So now what I'm doing, after compiling only preprocessor stage, I'm opening preprocessor content. After preprocessor stage, what is the preprocessor extension? .i. So vi space prog1.i. I'm opening prog1.i. See here, this is the preprocessor content. After this is a pure C code actually. See here, after preprocessor stage, your code is converted like this. And your program will be available at last. See here. See, this is your program. If you observe here, int x equal to 10, y equal to 20. I already told you take the screenshot of previous program. If you compare your screenshot and this program, after this there is a comment. But here comment is not there because preprocessor responsibility is to remove the comment. And here age, in place of age 25 will be replaced because macros replacement responsibility is preprocessor only. Then marks will be replaced with 100. If you observe in fun1 also, comments are removed and this 25, it is replaced with 25. Age and it will be replaced with 100 will be marks. Getting my point? So this is the preprocessor responsibility. I hope clear. Next, what is next stage after preprocessor? Now translator. I want to compile translator. What is the command to compile translator? gcc space -s. Now preprocessor to translator. What is preprocessor? prog1.i to -o prog1.s. Enter. Getting my point? So now what translator will do? Translator will convert that pure C code, means .i is the pure C code. It will convert that pure C code into assembly code. So you know assembly language, move x comma a, something like that. In your BTech, you know assembly language, registers, that, this. Getting my point? Move instructions, like that, some instructions are there, no? That is the assembly language. If you want to see that assembly, simply vi space prog1 dot s, enter. See here, this is the assembly stage. See here, move instruction, call, push, pop. This is the assembly. Who generated this assembly language? I already told. Translator generates assembly. It will convert from pure C code preprocessor program into assembly language. I hope clear. Two steps are clear. After this, we'll discuss errors also. That is very easy. But before that, we'll discuss step by step what is happening. Preprocessor done, translator done. So translator converts that pure C code into assembly code. You already seen assembly code also. Now what is third step? Assembler. So assembler converts assembly into object code. Object means binary, right? What is the command for assembler? GCC space -C, capital C, prog1 dot s2 -o -o prog1 dot o dot s2 dot o. Now this converts assembly to object. That move, push, pop instruction will be converted into binary. Who will convert that? Assembler. Enter. Now assembler, because of this command, that assembler will convert that program into object code, which is binary. Can I see the binary? Tell me, binary means zeros and ones. So can I see that? Vi space, what is the binary here? Dot o, prog1 dot o. This is binary. Sir, this is not binary, sir. Binary means zeros and ones, na, sir. But technically, you cannot see zeros and ones. You have to imagine these symbols are zeros and ones. Technically, you cannot see zeros and ones. Why, sir? Because zeros and ones meaning is the information is passing in on and off state. On means 1, off means 0. On, off. Information will send like this. You cannot see that practically. So zeros and ones means these are the zeros and ones, these symbols. This is object program. This is a binary program. These symbols you can notice it is a binary program. You can consider this is zeros and ones only. Getting my point? So assembler also done. I already told there is no errors in assembler. And linker. Let's see linker. GCC space prog1 dot s -o prog1 dot exe. This is the command for linker stage. What linker will do? It will add library functions into object file and it will generate executable file. And what it will do? It will link calling function to called function. Getting my point? It will link calling function to called function. Okay. Next, what is one more point? It will create startup function. Okay. Enter. Can I see executable file? Of course, executable file also binary file. You can see in symbol format. This is executable file. Now this executable file is also binary, but it contains that library is also added here. But previous in object file, there is no library. See here, libraries, puts, printf, libc. See, this printf and all is you are able to see, right? We'll see it is available in this prog.o. Getting my point? Next, Next, we'll check errors. So what is error? First error, preprocessor error. That is fatal error. See here, when you will get fatal error, fatal error is nothing but preprocessor error. If you have having any mistake here, instead of stdio.h, I'm writing wrong stdio.h. Whose responsibility it is? Preprocessor responsibility. So preprocessor has to detect this error. What is command for preprocessor? This one. Now I'm going to compile exactly only preprocessor stage. Is it able to compile? No, there is a preprocessor error. Header file is not correct. So fatal error will be generated. Who generated this fatal error means preprocessor will generate. Getting my point? Okay. Next. Next. So what I'm doing here, make it correct. stdio.h. Now, no preprocessor error. Now what I'm doing here, so no fatal error. Next errors, translator errors means syntax errors. When syntax errors are generated, if you are missing any semicolon. See here, I'm not giving semicolon y equal to 20. It is a syntax error. Whose responsibility to detect syntax error? Translator. It's not responsibility of preprocessor. Now I'm asking a question. I'm not giving semicolon here. So translator has to generate syntax errors in this case. Now see here, what I'm doing, I'm compiling preprocessor. Preprocessor code will compile successfully or not? Yes, it will compile successfully because preprocessor responsibility is not to detect syntax errors. Of course, in your code, syntax error is there, but preprocessor will successfully compile. This is no, preprocessor ka job is not to detect syntax errors. Now, next I'm compiling. Which one? Translator. Now this is the translator command. Now I'm compiling translator stage only. Translator able to compile or not? Definitely it will not compile because compiler will detect syntax errors. You are missing semicolon there. Getting my point? So you have to open proc.c and make it correct. Next, what is next is assembler. So at assembler, there is no errors. So now fourth one. What is the fourth one? What is the fourth one? Linker stage. This is the linker command. GCC space proc1.s -o proc1.exe. So when linker error will come? Very important. Linker stage is very important actually. See here. What linker will do? Linker links calling function to called function. Like see here. Whenever you call fun1 function, immediately it will jump to fun1 function definition. Consider if I'm calling fun3. I'm calling fun3 function. So immediately linker trying to map fun3 with fun3 function definition. It is searching for fun3 function definition. Is there any fun3 function definition in your program? You are calling fun3 function here. See here. Here you are calling fun3 function means telling link to fun3 function definition, but there is no fun3 function definition. Here there is a linking mismatch. Function name is different, function call is different, function definition is different. So now linker not able to link with calling function to called function. Now linking error will come. When linking error will come, definition and function call should be matched. Otherwise, linker not able to link with calling function to called function. Here main is a calling function with respect to fun3. Here main is a calling function and fun3 is a called function. But you are not defining fun3 at anywhere. Whenever you call fun3, linker is trying to link with fun3 definition, but fun3 definition is not available. That's why you will get linking error. Getting my point? So whenever you are compiling linker stage, means second stage, uh, like if you are compiling fourth stage, you have to compile first stage, second stage, third stage, then only fourth stage will be compiled. Similar, if you are compiling second stage, you have to compile first stage, then only second stage will be compiled. If you are compiling third stage, you have to compile first and second. If you are compiling fourth stage, first three stages you have to compile, then only it will work. First stage and second stage. Sorry, this is not second stage. Hyphen S. Second stage is compiled. And next, third stage. What is third stage? Hyphen C. This is third stage. So here you are getting linking error. Undefined in main function, undefined reference to fun3. Getting my point? When linking error will come, very simple, don't confuse. When linking error will come, calling function and called function should match. Here fun3 you're calling, there is no fun3 definition. If I give fun2, then fine. When fun2 is called, it will jump to fun2 definition. Why it is still getting error means because I'm directly compiling third stage. If I compile first, second, then compiling third, then it will not give error. See, first, second translator, now third. Now it is not giving error. Getting my point? So finally you will get executable file. This is fourth stage, so we will get executable file means /a.out. Who are not watching my first video, if you watch first and second, then you will get full clarity in this lecture. Who are already watching my first and second video, then you can able to understand very clearly this lecture. What is this /a.out and all? This already I discussed in class 1. Okay, so executed. So output came. So what we have discussed today, what is compiler, compilation stages and types of errors. In next class, we'll discuss about function mapping. Very important. So why execution starts from main and what is function mapping? Can we write program without main? That we will discuss. So I'm asking a question. If you know the answer, can we write program without main? You can write in comment section, yes or no. Okay, if you write a program without main, you can write S. Getting my point? Anyway, thank you.